let's start with Llama Factory. In that we have supervised fine tuning, and initially we have to install all the dependencies here, and then I have cloned the Llama Factory repository, which we will be using it later. And we also have to install Llama Factory in Colab, so that is here. And then just to ensure that GPU is running in our Colab, for instance I have used the T4 GPU, so just to check if it is working or not, just to check if we have the GPU environment in Colab. This is a simple line of code to check it. And yeah, this is simple GPU available line. And then we also need Hugging Face transformers for this, so here we have the Hugging Face login. And just to ensure all this code works properly, I have put up this line at the end that setup is complete. So moving forward, then we have fine tuning with LoRa. So to configure the training parameters for supervised fine tuning using LoRa adapters, and this also involves setting up the model path, datasets, and training specifics like learning rate and batch size. We can look all of these arguments here: the stage, model name or path, this is the model with that we are using, and the data set, the template, fine tuning type, LoRa target, output directory. And for the supervised fine tuning, and then we have the dump arguments and open the model path. And yeah, so here we are training it. So this is the training process. It almost took about 30 plus minutes, 30 to 35 minutes for this entire thing to supervised training. And we have the output at the end: training metrics, the epochs, and training loss, runtime, samples per second, and train steps. So it's pretty simple, it's just straightforward code for supervised. uh, and then we have DPO training. And then for this we also wanted to know that what directory the earlier supervised results are embedded into. And then we also list all the directories and the contents of their directories, and we also check if the source directory exists. And then we also import the LLM tuner for the DPO training process. And then just to ensure if the LLM factory is working properly or not, we use this particular uh, lines of code for getting the Llama factory version. So these are all the outputs. We do have the training process, and then we also verify the installation of LLM tuner, and we also have it installed. And then moving on to the code, we this is also the directory, verifying the directory structures. And then we have the um, final DPO training code here. Suppose the model name, the adapter name, dataset, template, fine tuning, LoRa, output directory, the gradient accumulation steps and all. And this we develop the command with all the necessary arguments for the DPO training. And just to ensure the training is starting, I have included this particular line just to ensure that all these code lines have worked perfectly, and started DPO training. And then we have the outputs here: DPO training. And next, PPO training. And similar to the DPO training, we just differentiate between this particular stage. That's the only difference, and few differences here and there depending on the PPO training. And similarly, the training starting PPO training, starting PPO training line. And then we also have the output for this script execution completed. So that's it for this part. let's moving on to the second part, LM Studio. And here I initially installed this particular Gamma 2B model, and then I loaded it into the LM Studio. And then this is the chat, this is the conversation that I had with the LLM model. This entire chat has been done locally, and it is very helpful as we don't have to rely on internet for this. So this is completely offline and it runs locally on your machine. I just took this 2B model because it's very small, and also the responses are also pretty good, but not like the 70 billion and those kind of models, but for a small size, for a limited size, these are pretty good responses. And we also let's go to the chat. Initially, hi, I'm Sai, and this is the response from the assistant. You can see it is using this particular Gamma 2B model. And then I gave it my resume, and I asked it to go through my projects and describe them. And this is the response from the assistant. Here is a breakdown of your project descriptions, highlighting key skills utilized in each: AI into your enterprise HR portal, integrative machine learning applications, and these are the skills. So it also gave me the skills that key skills that have been used in this particular projects. And this is really good understanding of what the projects that I have, as I know how my resume is designed and how the content is organized in it, and this is pretty good understanding of my resume. And there are also additional observations. Your projects consistently showcase your ability to combine technical skills with understanding business needs or real world applications of technology. This is a really good feedback to me. And let me know if you want to deeper dive into any particular project or have other questions. And then I asked it to rate my resume, and then it gave me the strengths, areas for improvement, revised resume structure suggestion, if at all there are any suggestions that it wanted to give me. These are the suggestions and additional tips and next steps. So yeah, for an offline model, that too for a 2 billion model, this, I think this is a very good output. So yeah, that's it for this part. Already installed Olama in my system. Let's try running the Gamma 2 model. Hi, explain SDLC. I have already ran the Llama 3.2 model here, but let's try that again. So this was the installation procedure, and then I asked it to explain cadence algorithm. Let's try that here again. Let's say pi and Olama run Llama 3.2. Yeah, I explain Talos and Rust. Yeah, so these are the Gamma 2 and Llama 3.2 models, and this particular Llama 3.2 is the multi-model. And going forward, we have REST API of Olama with examples. For that, let's go to VS Code. This is a simple Streamlit application where we can give the API access to these Llama 3.2 model. So this is pretty simple, which has a small text bar and a submit button, and below that we'll get the output from the Olama, and using the Llama 3.2 model. So let's run this. Streamlit run. Yeah. Okay. Hi. PSA. Submit. You're interested in learning more about data structures and algorithms. So this is the output from the Llama 3.2 model. So we can look at that here as well in the VS Code. So that's pretty much the same. So this is basically the API call to the Llama 3.2 multi-model. And going forward, we have run Olama in Google Colab. So firstly, I'm using a simple terminal. In this terminal, I have initially started running the Llama 2 model, and this is all the installation. And going forward, we have I asked the Llama 2 model to explain software development lifecycle. So this particular model was pretty slow. Since then, I moved to the Llama 3.2, which gave a pretty good output instantly. I asked it to explain cadence algorithm, and this was all the output that I got. And then going forward, I thought of using the LangChain as well, LangChain using Olama, but for some reason the connection isn't establishing. So let's try this again if it works now. Yeah, still the same issue. It might work tomorrow. So yeah, but it definitely does work because it's just the LangChain, and it's just an instance of the Olama model, and then we are invoking the model to generate responses. So it's a straightforward thing. Yeah, and that's it for this part. Moving on to Open Web UI, which is a offline web UI interface for your locally available Olama models. Since we are only working on command line interface for the Olama models, we can just provide a user interface for those models using this Open Web UI. I'm currently running it on my Docker container using this first command. So I ran it here, and it is running in this particular port. Let's go to it. So this is the Open Web UI, and here we can select a model. We also have record voice option, so it gives the your audio to text. And let's start with the Llama 3.2 because it's the multi-model that we have, so we can explore the multi-model features here. So let's start with the PDF. So this is my resume, and I'll ask what are all the projects that I have. Okay, since this is a 1 billion model, the outputs are not going to be that great, and let's try an image now. Based on the content surrounding the image, screenshot, various projects, and has expertise in areas such as software, data science, and machine learning, the image likely shows. Yeah, since this is a very small model, the outputs aren't that great, but this is how you are able to run the large language models or multimodal models locally in your computer being offline. So we can also try these record voice option. For example, let me just ask some technical question. Explain cadence algorithm. Let's try one more. Explain Dijkstra's algorithm. Yeah, so this is how this particular option works, and then we can upload files. We have this to hide, settings, audio interface. So there's a lot to play with here, And we also have download option, share, copy, overview. Pretty good stats here. And let's try overview. Okay, chat overview. Nice, pretty cool options. So it provides a lot of options for you to play with your locally available models. Yeah, that's it for this part. So moving on to Diffie. Initially I built a RAG engine. Let's go to it. And also before that, let's look at the knowledge dataset that we have used for the RAG engine, since we definitely need some sort of context for RAG to work better. So this is a PDF that has about 5 to 6 research papers about credit card fraud detection, and I merged them into a single PDF, and I have passed this as knowledge into the studio. And then when we go to RAG, this is the prompt that I gave. This initial context is the generated context from the knowledge, the PDF, and next human, the query that the human passes, and then what the assistant should respond. So based on the context provided, this context, please answer the human's query. If the context doesn't contain relevant information, use your general knowledge, but mention that it's not from the provided context. And here I have mentioned the context. We don't really need the variable, so I did not mention it here since we only have these three. And yeah, the context is here, the PDF, and let's run it. So this was the chat I had earlier with the chatbot, and initially hi, and then I asked if LLMs are used in any of the methodologies in these papers, and since none of them were used, the model worked accurately. I mean, the prompt, it followed the prompt, and this says that the context doesn't explicitly mention about LLMs or their methodologies. And I kept on asking about what are the techniques that are used in these papers, and these are some of techniques that have been used and any algorithms, and I have gone through all these papers, so I know that all these are present in the paper. So yeah, that's RAG, and let's go to agent. And here we have a customer service agent for Apple, and the prompt goes like this: your role is to assist customers with product inquiries and technical support for our smartphone line. And I have also added few extra prompts. Always be polite and professional, and if you cannot answer a question, offer to escalate the issue to a human representative. Since this is an agent, we can have an agent for a particular task. So there would be a main app which has multiple agents, and this particular customer service is one of those agents. And when depending on the user inputs in the main app, it we can select whatever the agent, and we can route the flow to any particular agent. So like this we have 3 to 4 agents, and I also allowed it to use all these tools for better, since it's customer service, so for better responses we do need online information. And then we can run this customer service. It is a pretty straightforward customer service tool, which basically asks answers all the questions that customers have. So next we have customer review workflow. So here we start, and then we have a question classifier. So depending on the positive review or the negative review, the LLM decides, and then passes the flow to the next step, where in the next step, depending on the positive review, we have a particular website that is loaded, and depending on the negative review, just to make sure what has gone wrong, the LLM asks for what issues the customer is facing, and then we have our after sales issues and transportation issue. And depending on both of these issues, there is further different flow, the different website that gets loaded, and user can get the information from those websites. And we also have this detailed process below that explains what all is going on in here. And then we have this variable assigner, and then the end. Let's run this. Let's go run app. For now, I'll give a positive review. As rating. Okay, currently we don't have the OpenAI limit. Okay, that's okay, that's cool. But definitely depending on the positive review, we get this website loaded and we have the entire output in that website. So that's it for this section. Thank you.